Ever pondered on how your body spends energy? Let's unravel this mystery together. Energy expenditure is a fascinating process that happens within our bodies every moment of every day. It's the way our bodies utilize the energy we take in through the food we eat. This energy is expended in three main ways. First, there's the basal energy expenditure, or B. This is the minimum amount of energy our bodies need to function while at rest. Then we have the thermic effect of food, or TEF, which is the energy used to digest, absorb, and metabolize the nutrients we consume. Lastly, there's activity thermogenesis, or AT, which is the energy burned during physical activity. Combined, these three components make up our total daily energy expenditure, or T. Understanding these components can help us optimize our energy use. Starting with the basal energy expenditure. Let's get to know this fundamental concept. The basal energy expenditure, also known as B or basal metabolic rate, BMR, is the bare minimum of energy that your body needs to function. This is the energy your body uses even when you're not doing anything at all, like when you're sleeping or just lying on the couch doing absolutely nothing. Now you may think, how much energy could we possibly need when we're doing nothing? Well, even when we're at rest, our bodies are still working hard, our hearts are pumping blood, our lungs are breathing, our brains are processing information, and our cells are performing all sorts of complex chemical reactions. All these processes require energy, and that's what the B covers. The B is essentially the energy needed for 24 hours of complete physical and mental rest. It's the energy used when you're not eating, moving, or even thinking hard. It's calculated in a thermoneutral environment, which means an environment that doesn't make you feel too hot or too cold. So your body doesn't need to use energy to warm up or cool down. What's fascinating about the B is that it remains remarkably constant on a daily basis. Despite the ups and downs of life, the energy your body needs to simply exist doesn't change much from day to day. This is because our bodies are incredibly efficient machines that have adapted to use energy as sparingly as possible. So, to put it simply, the basal energy expenditure is like the idle power of your body. It's the baseline energy your body needs to function, even when it's not in action. It's like the power your computer uses when it's on, but you're not actually using it. Or the energy your car uses when the engine is running, but it's not moving. So, B is the energy our body uses when it's at complete rest. It's a fundamental part of our daily energy expenditure, and understanding it can help us better manage our energy use and overall health. Now let's dive into resting energy expenditure. This term, also known as resting metabolic rate, or RMR, refers to the energy our bodies expend in carrying out the activities necessary to keep us alive and functioning. Picture your body as a complex machine, requiring a certain amount of fuel to keep all its parts working. This fuel is your resting energy expenditure. Let's break it down. Think of your body's core functions. They include respiration, circulation, the synthesis of organic compounds, and the pumping of ions across membranes. All these activities require energy. Your brain, the command center of your body, also needs energy to function effectively. Similarly, maintaining a stable body temperature requires energy. All these elements together form your resting energy expenditure. Now you might be wondering how resting energy expenditure is different from basal energy expenditure, which we discussed earlier. The key difference lies in the level of activity. While basal energy expenditure represents the absolute minimum energy your body needs to stay alive at rest, resting energy expenditure includes the energy needed for the normal functioning of your body and maintaining homeostasis. This is why resting energy expenditure is generally higher than basal energy expenditure. To give you a clearer picture, resting energy expenditure is typically 10 to 20% higher than basal energy expenditure. Simply put, resting energy expenditure includes the energy used by your body to carry out its normal functions and maintain a stable internal environment. But it doesn't include the energy used for physical activities, thermogenesis, or any other form of energy expenditure. So, in essence, resting energy expenditure is like the fuel your body needs to keep all its systems running smoothly. It's the energy you need even when you're not doing anything physically demanding. It's the energy your body uses to keep your heart beating, your blood circulating, your brain functioning, and your body temperature stable. So, RE is the energy we need for our normal bodily functions. What influences our resting energy expenditure? To answer that, we need to look at several factors, starting with body size and composition. This has the most significant effect on our resting energy expenditure. A larger body size will require more energy to maintain basic functions, which in turn increases REE. Similarly, body composition, The ratio of fat to muscle in your body also plays a crucial role. Muscles burn more energy than fat, even at rest, which means a person with more muscle mass will have a higher REE. Next, let's talk about age. Interestingly, our resting energy expenditure is highest during periods of rapid growth, like in the first and second years of life. During these times, infants may store as much as 12 to 15% of the energy value of their food in the form of new tissue. However, as we age, the energy requirement for growth reduces significantly, causing a decline in REE. After early adulthood, there's a decline in REE of 1 to 2% per kilogram of fat-free mass per decade. But don't lose heart, regular exercise can help maintain a higher lean body mass and consequently a higher REE. Lastly, let's delve into the role of body composition, particularly fat-free mass or lean body mass. This is made up of all the metabolically active tissue in your body and is the primary predictor of REE. It contributes to approximately 80% of the variations in REE. This is why athletes with greater muscular development have an approximately 5% higher REE than non-athletic individuals. Even the size of certain organs like the liver, brain, heart, spleen, and kidneys can significantly affect REE. These high metabolic rate organs account for approximately 60% of REE. Even small individual variations in the size of these organs can lead to significant changes in REE. So, our age and body composition significantly affect our resting energy expenditure. Let's take a quick recap of what we've learned. Energy expenditure, the process by which our bodies burn calories, is comprised of three key components: basal energy expenditure, or B, the thermic effect of food, and activity thermogenesis. Our B reflects our body's minimum energy expenditure, essentially the energy required to keep us alive when at rest. On the other hand, resting energy expenditure, or RE, is the energy we expend to maintain normal body functions and homeostasis. It's important to note that our REE is typically higher than our B by 10 to 20%. Various factors influence our resting energy expenditure, with body size and composition playing the most significant roles. Age and growth periods also impact our REE, as does our level of physical activity. Remember, understanding and managing our energy expenditure is a key step towards optimizing our health and wellness. Mastering our energy expenditure helps us optimize our health and wellness.